Let's draw a circle. And there we go, that's nice. And now we're dealing with the arc length formula. So what we need to know is what is an arc? An arc really is just the distance on the circumference, or a part distance of a circumference between 2 points. So it's not the whole circumference, it's sort of part of it. We call that an arc, and typically we let S is equal to arc. Now if we take the center of the circle, then we can also define the arc with sort of an angle. So we say the angle theta with the radius r will subtend an arc S. And we already know that the circumference of a circle is 2 pi r. So knowing that, therefore S is going to be equal to theta over 360 degrees, or 360 is because it's that part of the circle that we're dealing with. So if the angle was 60 degrees, for example, then it's 160 over 360, it's part of the circle. So it becomes theta over 360 times pi r, and that's how we can go ahead and calculate the arc length. So if we look at an example, example 1, calculate S when r is equal to 5 centimeters. In other words, a circle with a radius of 5 centimeters, and theta is 60 degrees. So what we do is substitute those values into the little formula we've got. So it becomes 60 over 360, I forgot a 2 there, no, times 2 pi times 5. And you can whack that whole thing on the calculator, but what we might do is just muck around with that a little bit. And 2 times 60 is 120. So we get 120, 5 times 5. It's actually a third. So 120 over 360 is a third. And therefore I get pi over 3 times 5. And we get 5 pi over 3. Now we have just, we wouldn't normally do that. You can actually just enter all of that onto the calculator. And if you do that, you'll get 5.236. But if you wanted the answer in terms of pi, you could do what I've done just before. Now, all of this is how to calculate the arc length using degrees. And fortunately, the whole thing becomes a lot easier when we work in radians. So note that down. Much easier in radians. And there are some things that we just can't do in trigonometry without radians, but this is certainly one where it's a lot easier. So let's have a look. We're going to do the same thing. So we've got a fraction of the part of the circle. Okay, so there I've got some fraction theta, but it's not over 360 now, it's over 2 pi, because in radians, of course, a full circle is 2 pi. Now what's really interesting here is that this pi, 2 pi, that cancels with that 2 pi. So what we're left with is the formula S is equal to r theta. And that is the equation for the arc length. So this is the arc length formula. And where theta is in radians, and that's really the only one we need to know. We don't bother with that other thing. It's just too awkward to use. This is just much easier. So let's look at another example. In fact, we'll do one very similar. So example 2, calculate S. All right, given that r is equal to 5 centimeters, and theta, can't spell and theta is equal to pi over 3. Now we just use S is equal to R theta, so S is equal to 5 times pi over 3. Now you might realize actually that pi over 3 is 60 degrees, so this is exactly the same what we ended up with before, but a lot quicker. 5 pi over 3, and again on the calculator it still comes out at 5.236 centimeters to 4 significant figures. So it is just easier to do. Let's look at a second example. Here's another example. Calculate R if S is equal to 125 centimeters and theta is equal to 3 pi over 2. So we set that out. S is equal to R theta. Do some substitution. So 125. I'm trying to calculate R, and I've got 3 pi over 2. So R then, just rearranging that, we're going to divide by 3 pi over 2, which is the same as multiplying by 2 over 3 pi, and we can just do that on the calculator. Then we get 26.5 centimeters to 3 significant figures. I'm just rounding because that's accurate enough. Now here's just a little bit extra to think about. If we've got a circle here like this, and we'll try and draw this so that the radius, if R is equal to 1, it means it's 1 there as well. Just take that, make it a little bit closer, there we go. And the arc length here is also equal to 1, so if S is equal to 1, then theta is equal to 1. All right, so that is, in this situation here, if they're equal, that angle is also equal to 1. In fact, that's how we kind of define, is one way of defining what a radian is. It's an arc length of 1, a radius of 1, and theta is equal to 1. Makes sense in terms of the arc length formula, because if S is equal to R theta, then what is S when we get 1 times 1? S is equal to 1. So we can use that knowledge as well, sometimes to quickly solve other problems. And we might say to ourselves like this: what is the angle theta when S is equal to 3 and R is equal to 3? We'll make it centimeters. Well, you should realize now that if I've got S is equal to R theta, S is 3, R is 3, then theta must be equal to 1. Hopefully that kind of makes sense, because all I have done is I have made that circle 3 times larger. I have made R 3 times larger, S 3 times larger, but everything is in proportion, and therefore that angle stays the same.